Hello viewers, in today's session we are going to discuss another important and conceptual problem from integration. And in this session we are going to discuss this problem where we are given a function f of x which is defined by this equation f of x is equal to cosine x minus pi square sine x integral 0 to pi by 2 f of t dt. Then we have to find f of x, and further we have to show that this function f of x is strictly decreasing in this interval, that is 0 to pi by 2. So here first we'll find out the form of the function f of x, and then we'll see how we can prove that this function f of x is a strictly decreasing function in this given interval, right? So let us start with this equation. See, here we have f of x is equal to cos x minus pi square sine x, and here we are given this integral, right? So let us take this integral as say alpha. So we can take alpha is equal to 0 to pi by 2 f of t and dt, because whatever be the function f of t, when we calculate this integral is going to give us some number, say alpha, right? So taking this integral as alpha, we can now write this equation in terms of alpha as f of x is equal to cos x, then we have minus pi square sine x, and here we have alpha, right? Now let us observe this equation. Now this equation is f of x is equal to cos x minus pi square sine x alpha, right? So this is a function of x, and here if we replace this x by t by considering or by using the concept of dummy variables, and if we replace this x by t, then we can easily get f of t is equal to cos of t, then we have minus pi square sine t, and here we have alpha. So this is our equation number 2, right? Now let us substitute this value of f of t in this equation. So we can now write alpha is equal to 0 to pi by 2, and for f of t we can now write cosine t minus pi square. We can take alpha in front of sine t. So here we have alpha, and then we have sine t, and here we have dt. So now we have to evaluate this integral. Now the integral of cosine t is simply sine t, and here pi square alpha is a constant, so we can now write pi square alpha, and the integral of sine t is minus cos of t, and the limits of integration are from 0 to pi by 2. So in other words, we can also write this equation as 0 to pi by 2 cos of t dt, and then we have pi square alpha and 0 to pi by 2 sine t dt. So we can also write this integral like this, or integrating the terms, cosine t has integral sine t, and sine t has integral minus cosine t. So now we have sine t, and here minus and minus multiplied together gives us positive sign, and here we have pi square alpha cos of t, and limits of integration are from 0 to pi by 2. Now let us substitute the limits and taking the difference. So the value of alpha is now sine pi by 2, then we have pi square alpha cos of pi by 2, and then we have minus sine of 0 plus pi square alpha, and here we have cos of 0. Now sine pi by 2 is 1 and cos pi by 2 is 0, so this term is 0, and then sine 0 is 0, and here we have cos 0 is equal to 1. So we have simply pi square alpha times 1, that is pi square alpha. So now we have alpha is equal to 1 plus 0 is 1, and here we have minus pi square alpha. And solving this equation for alpha, we can now write alpha plus pi square alpha is equal to 1. Alpha, taking alpha common, we have 1 plus pi square is equal to 1. So alpha is equal to 1 over 1 plus pi square. So now getting the value of alpha is equal to 1 plus pi square, we can easily conclude that the value of this integral, that is 0 to pi by 2 f of t dt is equal to 1 over 1 plus pi square. So this is also an important deduction from the value of alpha. Now let us substitute this value of alpha over here. So we have f of x is equal to cos x minus pi square sine x, and here we have alpha is equal to 1 over 1 plus pi square. Right. So this is the required form of the function f of x. So f of x is defined as cosine x minus pi square sine x over 1 plus pi square. So now to prove the second part, that is f of x is a strictly decreasing function in 0 to pi by 2, we have to differentiate this function f of x. So the derivative f prime of x is equal to the derivative of cosine x is minus sine x, and the derivative of sine x is cosine x. So we have pi square 1 plus pi square, and sine x has derivative cosine x. Now taking negative sign outside the these two terms, so we have sine x plus pi square over 1 plus pi square and cosine x. Right. So from this expression we can see that f prime of x is going to be less than 0 for all values of x belonging to this interval, that is 0 to pi by 2, because this interval it gives us the first quadrant, and in the first quadrant that is sine x and cosine x both are positive. So in the first quadrant we have sine x and cosine x both being positive. So this term is going to be always positive in this interval, and here we have the negative sign. So f prime of x is always less than 0 for all values of x belonging to this interval, and this is the condition for a function to be a strictly decreasing function. So if the slope of the tangent is negative, then the function is said to be a decreasing function. So this is how we can prove that the function f of x is a strictly decreasing function in this interval, because the derivative is negative or it is less than 0.